All right, day 2, implicit differentiation. We're throwing some products in here. This is going to be so exciting today. There are no toothpicks needed in today's lesson. Okay? Remember, implicit differentiation, all it is taking derivatives of equations that are not solved for y. Granted, I can solve this thing for y. I don't want to do it. We need to learn our implicit differentiation. Notice, there's a product here. In order to see the product, I want to take it as x squared times y squared equals 5. Okay? My product is between there because it's a product. It's a function times another function. And I'm taking my derivative in terms of x on all of these problems. Okay? We're finding dy dx on all of these particular problems. So I need to, every time I take the derivative of a letter, I have a chain rule because this is technically something x squared. The derivative of something squared is 2 something to the first times the derivative of the something with respect to the variable we're differentiating to. So derivative of the first term times the second term plus the derivative of something squared, that's 2y, times the derivative of my something, okay, times the first term equals the derivative of 5 is 0. Well, all I would do is I would call this 2x y squared because I know that is actually 1, so I'll never write dx dx again whenever I'm taking the derivative of x. We're going to be on the notion that we don't need to do that. Plus, this is going to be a 2x squared y times dy dx. I just cleaned it up here a bit, equals 0. So I know 2x squared y times dy dx equals negative 2x y squared. So obviously, dy dx, that's a crappy y, ooh, that's even worse, equals negative 2x y squared over 2x squared y. And of course, I'm going to reduce this thing to say dy dx equals, okay, had a fraction, got a negative. There's one more x in the bottom. There's one more y in the top. There's my derivative in terms of both x and y. Notice, when I took the derivative of y, it produced the dy dx. When I took the derivative of my x, it produced a dx dx, which is 1. Okay, so I'm not going to do that anymore. We're going to make sure we are on par here. Check it out. Another product. We're going to take this derivative. We have something cubed times something to the 4th equals negative 24. So the derivative of my first term, it's a product rule, like I said. It's 3x squared times the derivative of my something. Well, that's a dx dx. It's just 1, so I'm not going to write it. Times my second term plus the derivative of something to the 4th is 4 something to the 3rd, but that's times a dy dx with my chain rule, okay, times my first term, x cubed, equals derivative of negative 24. It's 0. So I'm going to say this is 3x squared y to the 4th plus 4x cubed y cubed times dy dx. Notice I write my letters in alphabetical order to keep things easy for me. 4x cubed y cubed dy dx equals negative 3x squared y to the 4th. So then I need to divide by 4x cubed y to the 4th. So dy dx, ooh, crappy x again, is going to be negative 3x squared y to the 4th over 4x cubed y to the 3rd. And of course, I got to reduce that, dy dx, because who wants to plug numbers in there and take them to powers if I don't have to? Negative 3 and 4 do not reduce. I do see I have an extra x in the bottom, and I do see I have an extra y in the top. So that is my derivative of 3x, or x cubed times y to the 4th equals negative 24. Its first derivative is negative 3y over 4x. So what we're we're going to do here is I would like you to try to pause this. Ooh, should we try this one yet together? Let's try this one yet together because the left side I have no product. The right side I do have a product. So I'm going to look at this as an x cubed plus a y to the third equals, I like to nest that constant of 18 with one of those terms, and this would be times a y. So I have a product on the right side, but not on the left side, okay? So what I got to do here is I got to take the derivative of this term. Well, that's 3x squared dx dx, which is 1, plus 3y squared times dy dx equals, now I got to take the derivative of my product. Well, the derivative of the first term is 18 times the second term is y, plus the derivative of my second term here, well, that's just a dy dx times the first term of 18x. Whoa, things are getting a little wonky on me now. See how I got a dy dx on both sides? Well, I need to get those on the same side, and I want to get all my other stuff on the other side. So I'm going to look at this as a 3y squared times a dy dx minus 18x dy dx equals 18y minus 3x squared. So hopefully you see I just moved this guy over here. I moved this one over to this side of the equation because I got to get dy dx alone. Well, check it out. If I look at these two, what do they both have in common? They both have a dy dx in common, such that if I factor them out, that's gone, and that one's gone. So now I can say dy dx equals 18y minus 3x squared divided by 3y squared minus 18x. Well, if I look at that, yes, I can simplify that a bit. Because as I'm looking here, I can take a 3 out of the numerator. That's going to give me a 6y minus x squared over, take a 3 out of the denominator. That's going to give me a y squared minus 6. I know those 3's are going to reduce, so this derivative is actually going to be 6y minus x squared over y squared minus 6. So if I need to know the slope of whatever that curve looks like, I need both an x and a y. I need the whole ordered pair to plug in to find my slope at that point. Okay? So what's going to happen? We're going to generate more than one dy dx sometimes. So the goal is getting our algebra skills to get this stuff put together. All right? And we're going to come on to this next one. Really not a hard one here, because we've been taking this, oh, I don't need implicit differentiation for this one, but the derivative of y to the first, if you're wondering why I just got a dy dx over there, that's really 1 y to the power of 0, chain rule, dy dx, okay? And you know that's 1, so 1 times 1. So when I'm taking the derivative of just that plain old y, but I'm taking it in terms of x, I get dy dx equals 6x dx dx minus 6 dx dx, which is 1. So dy dx equals 6x minus 6, okay? So what I'm going to do is I want you to hit pause and I want you to try this one, but before you try this one, notice I can take the derivative of that guy, I can take the derivative of that guy, I can take the derivative of that guy, but nested here in the middle, notice I have a wonderful little product in the middle that I need to separate, okay? So hit pause and see if you can get this derivative on your own. Hopefully I'm back. Derivative of this first one is going to be 2x minus, ooh, I don't like that minus, but I go minus a big fat product. And my product is the derivative of the first term is 1 times the second term is a y plus the derivative of that second term, that's going to be my dy dx, times the first term of an x. And notice why I took this as a product, because this negative is going to distribute in here in the end, plus this is going to be a 2y dy dx, because that's a chain rule in there, equals, what's the derivative of 3? Big fat 0. Okay? So I'm going to look and say 2x minus y minus x dy dx plus 2y dy dx equals 0. I distributed that negative. Now what I want to do is, in my mind, I want to nest these guys here on this side. I want to move the 2x over here. I want to move the y over there. So as I'm factoring out my dy dx, what I have is negative x plus 2y. That's what that equals. So I know dy dx equals negative 2x plus 2 divided by negative x plus 2y. Okay? And what I need to always be able to do is realize that there are equivalents here. Notice this is equivalent to, if I pulled this negative out of the bottom, I would have x minus 2y, and there's a negative, but if I took that negative and I buried it into the top factor there, wouldn't I just have 2x minus 2? So I need to be able to look at this and make sure I didn't make a mistake. So I'm going to do that right now. I knew I made a stupid algebra mistake here, and you guys are all back there laughing at me. And I moved this guy over, and I called it 2, but it's really not 2. That little bugger has got to be a y, which means this little bugger right here is a y. Now I'm cooking with grease. Now that is equal to, well, that's going to give me x minus 2y and 2x minus y. It might look like that, or it could look like that, or they might say 2y, excuse me, let me bring this first one up here. Looking at equivalence, possibly they have a 2y minus x and a y minus 2x. You have to know all of the different equivalents that you could be looking for, okay, to make sure you get them right. And we're going to move right along here to number 8. And number 8, well, let's do it. Notice this side's all in terms of x. I got a chain rule. That's going to be 2 times 3x minus 7. That is now to the first power, but I never write my first power, so I won't. But that's times by the chain rule of 3 inside there. That equals 3 times 2 is 6y squared times my chain rule of dy dx. And I do have a dx attached to this 3, but it's 1, so I didn't do it. So I really have 6 times 3x minus 7 equals 6y squared times dy dx. So I know dy dx actually equals 6 times 3x minus 7 over 6y squared. And of course, I can reduce that 6 and that 6 out. So I can see my derivative right there is going to be 3x minus 7 over y squared. Is it the same if is it okay if I don't put the parentheses on it like that? Yeah, I don't care if you got them on there. They're not needed anymore. But that is an equivalent, okay? So from here, ooh, go Warriors, go you bunch of potlickers out there. And we're going to rock on to number 9. Number 9. So we're going to take number 9. I hope you pause it and try number 9 on your own here real quick. I would really greatly appreciate that. And I'm going to do this one in fuchsia. Notice I got a product in here, okay? So I'm going to keep rolling. Hopefully you pause. Derivative of my first term is 2x times dx dx. Derivative of the first term times my second term plus the derivative of my second term there. Well, that's just a straight up dy dx times my first term, which is an x squared, plus, derivative of that guy, that's just going to give me a dy dx equals derivative of 2x, that just gives me a 2. Now notice, I'm going to say dy dx, x squared times dy dx plus dy dx. What does that equal? 2 minus 2xy. Now I'm looking at this little guy because I know I can factor out my dy dx. But notice what happens here. What happens here is this first one goes away when I pull it out because it's times x squared. But what happens when I factor a dy dx out of a dy dx? You're right. There's a big fat 1 that goes there. So in the end here, dy, my derivative of y in terms of x is going to be 2 minus 2xy over x squared plus 1. And there's nothing for me to factor and reduce, so I am donezo on that 1o. And then we run into the ones like here. Well, we could solve this for y if we really wanted to with an inverse sign, but why would we want to do such a thing? I don't know. I like my implicit differentiation. It really goes well. Check it out. I've got a product. Yes, I do. So I'm going to take first term, second term. The derivative of that first term is 1 times the second term, which is a sine y. Okay? That plus the derivative of sine y. Derivative of sine is cosine, that same thing. Chain rule times that, that's times a dy dx, times my first term equals the derivative of 1 is 0. So I know dy dx times x cosine y equals negative sine x, right? And, that's not a sine x, you big dummy. That's a sine y. Makes a huge difference because the sine is y. And dy dx equals negative sine y divided by x cosine y. Well, I need to look for equivalence. Okay, I do need to look for equivalence. Well, that's really, what is that really? It's really negative 1 over x times sine of y over a cosine of y. What is that? It's really negative 1 over x times a tangent y, and I could call it like that, or I could call it a negative tangent y divided by an x. That's what that wonderful dy dx equals. Okay? This next one, we're going to have some options. Okay? Notice every time we've just been finding dx, dy, dx. What does that equal? First derivative. Okay? Find d squared y over dx squared. What is that? That is my second derivative. Okay? These get dicey, guys. These get dicey. There's a couple ways to do these. Okay? Well, I could say, okay, you pick which way you like it. If I took my first derivative here, that's 2x plus 2y times chain rule dy dx equals 0. Well, that means 2y times dy dx equals negative 2x. So you probably remember dy dx equals negative 2x over 2y. So dy dx equals negative x over y. There's my first derivative, okay? I can take it from here if I wish. So now to get my second derivative, okay, now I would use a quotient rule and I would say d squared y over dx squared equals, this is a quotient now, okay? And that's derivative of the top is negative 1 times the bottom, y, minus the derivative of the bottom, that's my dy dx, times the top, which is a negative x, all over my bottom squared. Okay? So what does that equal? Well, that equals negative y minus, what the heck? What the heck is this dy dx business in here? What is that business up here? Right there, isn't it? I didn't need to go up at all. So dy dx actually equals negative x over y, because see, I need this derivative in terms of x and y. Therefore, I have to plug my first derivative into my second derivative over y squared. And I'm going to keep chugging along here and say, well, that equals negative y. That's a negative, a negative, a negative, and a negative. This is going to be minus. That's over 1. So that's x squared over y, isn't it? Over y squared. Well, most people are going to look at this and they're going to say, ooh, I need common denominator. That's going to be a negative y squared over a y minus an x squared over a y squared, which technically is negative y squared minus x squared over y squared, which is over 1. Remember, we're going to multiply by the reciprocal here on a complex fraction. So what do I get? I get negative y squared minus x squared over y to the third. Is that completely simplified? That is not completely simplified. Okay, dx squared. Why not? Because in the very beginning, I knew x squared plus y squared equals 9. Okay, and I can make this one much simpler. This doesn't always happen, but if I focus right here on that numerator, well, isn't negative x squared minus y squared, wouldn't that equal negative 9? So that means I can substitute this business over here, and I can say d squared y over dx squared actually equals negative 9 over y cubed. Much nicer looking derivative for me, okay? And that's one way to skin that cat, okay? The other way to skin that cat is if you know that you are taking a second derivative, okay? What we're going to do is we're going to come up here and we're going to say x squared plus y squared equals 9. So I can take my first derivative, and I don't have to solve out my first derivative right away, but I do know this is going to be 2x plus 2y times dy dx, right? Equals 0. Well, from here, I can continue to differentiate if I wish, okay, if I wish to do that. However, I have to identify product here. Okay, so if I did do that, notice I didn't say do, I said did do that, the derivative of this guy is 2. Plus, that is a derivative of a product. The derivative of the first term is going to be 2 times dy dx times the second term, which is dy dx, plus the derivative of the second term is d squared y over dx squared, that's my second derivative, times the first term equals my second derivative of 0 is 0. So what do I got? I'm thinking, here's u, here's v. Okay, so I got u prime here times v plus v prime times u. So I use my whole thing along here. So what did I go as I come along? I got 2 plus 2. Well, this is really a dy dx times itself, so it's squared, plus a d squared y over a dx squared times 2y equals 0. Well, now notice I want to solve this guy out. Okay, that's what I want all along. So if I did that, I would say d squared y over dx squared equals, okay, I got negative 2 minus 2 times dy dx quantity squared over 2y, right? Okay, everybody's got that, I hope. But we still have a problem. We still need to know what the heck was my first derivative. Now, I can also come in here because I can reduce that 2 and that 2 and that 2, which kind of makes this a little bit nicer. 1, and now I only have dy dx squared. Well, what was dy, excuse me, dy dx squared? Well, I still got to come up here to my first derivative. I'm still going to have to solve it. So I can see that that's still negative x over y, right? So this is going to give me negative 1 minus negative x over y quantity squared over y. Well, what happens when I square that? I get negative 1 minus x squared over y squared over y, don't I? Well, common denominators. That's going to give me, this is going to give me y squared over y squared, it's still negative though, equals minus x squared over y squared over y over 1. And a lot of people don't like my multiply by the reciprocal. Okay, that's fine. I think typically what you guys did last year is x squared over y squared when you took it y over 1. I think a lot of you guys were taught, hey, let's multiply both top and bottom by 1 over y. Well, that's the same thing because now that denominator is 1. And that's going to give me negative y squared over x squared over y cubed. But again, I'm still running into that back substitution that I can look at, okay? So I want to take this little guy right there, and I'm going to drag him up a little bit further here, and I'm bringing him up to the top, right to here, and I'm going to get rid of that, and I'm going to say we're back to d squared y over dx squared equal that. I still have that substitution I can make back here. So I know if x squared plus y squared equals 9, I do know the opposite of x squared minus y squared equals negative 9. So I can still plug that in and say negative 9 over y cubed. You pick which one you want, okay? It really doesn't matter. I'm going to say either way, you're still going to have to know your first derivative because sooner or later you got to plug it in, do the operation around it because the first derivative times the first derivative is the first derivative squared, and that's what this says right here. It's not, this is the first derivative times the first derivative. That is the first derivative times itself or squared, okay? I'm not multiplying my differentials. My second derivative comes when I'm taking the derivative of the derivative. That is where that guy came from right there, all right? They're kind of tough problems. So what we're going to do is we're going to do a little application here. Let's find the equation of the line tangent and normal to x squared, 3x squared minus y cubed equals 11 at the point 1, negative 2. Not a big deal. They gave us a specific point to find it at, so we got the point. Now we need the slope. Okay? The slope, if I need the slope in calculus is find the derivative. So my derivative of 3x squared is 6x. And again, it's a chain rule because it's really 3 something squared is 6 something to the first times the derivative of the something. I want to drill that in because implicit differentiation, it's all about the chain rule. But because I'm taking the derivative of the letter with respect to the same letter, I do not need my differential notation on it. But when I come to this next one, minus something cubed is 3 something squared times the derivative of the something, I have a dy dx coming out of that equals derivative 11. No, it's not. It's 0. It's a big fat 0. Don't ever call it 11. So dy dx equals negative 6x divided by negative 3y squared, which reduces to 2x over y squared. That is dy dx, right? Hopefully I did that correctly. Then there's my derivative, the slope at the point 1, negative 2. Well, that means dy dx is going to equal 2 times 1 over negative 2, and I got to square that, so that's 2 over 4. So my slope here is a half for the tangent line. Okay, so if I know that's my tangent line, I didn't drop the sign. Hold on, I got to check and see if I dropped the sign. I hope I didn't drop the sign. I did not drop the sign. I don't think I did. No, I didn't drop the sign. So, my tangent line is going to be y plus 2 equals 1/2 times the quantity x minus 1. There's my tangent line. My normal line is perpendicular to tangent. Therefore, slope equals negative 2, right? And I'm going to triple check this, but I believe I'm right. So then that is y plus 2 equals negative 2 times x minus 1. I'm going to go back and check my work because my notes show something different, but I don't think I dropped a sign. Be back. Okay, I'm back. I confused myself. I did my notes wrong, but I did the problem in the video right. I dropped a sign in my notes, and I have confirmed I did not drop a sign on my video. But I did promise Maddie that this would be about a 58-minute video, or 58-minute long video. So we got another problem here. What I really want you to do, we're not going to do it on the Inspire, okay? No Inspire, because I don't feel like firing it up. So we're going to go no Inspire, pause it, find my first, this means first derivative. Find it and let me know what it is. And I'll be back with the answer, but I really want you to try. These are super important. And we're back for the attack. The first thing I want you to notice, really big, there's a product hidden in there. X times Y is a product. So we're going to come through. Derivative of x squared is 2x. I always like to kind of do this with my products and separate them out. Derivative of the first term x, so I get 1 times y plus the derivative of y is dy dx times x plus the derivative of y squared is 2y times dy dx equals 0. The next thing I like to do is I like to clean it up, and I like the product because a lot of times there's a minus there, and when that minus is there, people forget to distribute it to the product. There wasn't, so it just really got rid of my parentheses. In the next step, what I like to try to do to shorten things up, anything without a dy dx, I like to bombard to the other side, and anything with a dy dx, I like to factor it off each one right away in the same step, so I turn into something like that. And I just really kind of shorten out my work in there. So I do get dy dx times x plus 2y equals negative 2x minus y. I hence divide by x plus 2y, and I find out dy dx equals negative 2x minus y over x plus 2y. And I could find the slope anywhere on the curve then. I just need an x value and a y value. I need an ordered pair to find it. Also, if it were multiple choice, please make sure you are looking for potential equivalence, because I can take this little bugger and I can suck the negative off the top, factor it out of each one, and put it in the front of the equation and see an equivalent of it. Other than that, this is pretty complicated stuff when you hit your second derivative. They are tough. They are very easy to make mistakes. But it was an exciting lesson. Hope you guys have a good rest of your day. Bye-bye.